because I wasn't that concerned with it. But it is a pre-calc thing for sure. So the difference of cubes and the sum of cubes. I'm going to, above these, write the general rule for you guys. So if you're factoring and you have a perfect cube minus a perfect cube, there's your difference. It comes up in the subtraction. It factors into a binomial times a trinomial. And you just sort of have to memorize this rule. It's not terribly difficult, but it's more difficult than the difference of perfect squares, because that's just nice conjugates. So the binomial just sort of reflects whatever you see. It's the cubed root of the first term, which is just a. If it's a minus, it stays a minus. And the cubed root of the second term is just b. And then when you jump to the trinomial, your first term of your trinomial is whatever that first term was, but just square it. So that's just an a squared. Your last term is just the last term squared, so b squared is b squared. And your middle term is just going to be the product of these two, ab, but the opposite sign, so plus ab. Who are my two that had Mrs. Zigai? You two? You two. Did she do same, opposite? Oh, you didn't. Oh, okay. So, well, when she teaches it to some of her kids, when she does teach it, she says this like soap thing to help people with the signs. Do the hills do that? Oh, the hills do that too. Okay. So, to help you with the signs, if this is subtraction in the original, it's same. So if that's subtraction, then that's subtraction. That's what they mean by same. This one is opposite. So if this is minus, this is plus, and this one is always positive. So the words, is it called an acronym?
Yeah.
Same, opposite, always positive can help you with the signs of all of that. It's just a little something if that helps you. Okay? So when we go and look at the sum of two cubes right now,
What does it stand for?
same, opposite, always positive. And it's getting at the signs,
Okay.
like negatives, positives. If you have the sum of perfect cubes and you're trying to factor that, it's the exact same thing, but just really your signs are going to be different. So the cubed root of that, a cubed is still a. The cubed root of b cubed is still b. But when you use the s from soap, same sign means if it started as a sum, you keep it as a sum. And then your first term of your trinomial is still that squared, so a squared. Same sign, then comes the opposite sign. And so multiply these two together, ab, that's your middle term. And the last one is always positive, so that's a plus. And then that term squared gives you the last of that. So that's the structure. Now we have to use that structure in problems that actually have terms other than a cubed and b cubed. So on the first difference of cubes, one here, I know this is a perfect cube because it has a cubed root of x. I know this one's a perfect cube because it has a cubed root of 1. So when I go to set up my binomial, those cubed roots, the x and the 1, make up my binomial with the same sign. And then is it Tommy? No. What's your name? Andrew. Is Tommy Barber not here? Gotcha. Andrew, tell me, given that you've never seen this before, can you take a stab at what would go in the trinomial? Oh, we got a quick one here, guys. X squared plus x plus 1 wastes no time. First term squared, last term squared, product of the two, opposite sign. Good. In B, I like to set up my binomial and trinomial structures just so I can envision where I'm going. What would my binomial look like, do you think? Tori? Very good. 3x plus 2. And do I need to pause there? I see some funny faces.
No, I had.
So cubed root is 3x, cubed root is 2. And the trinomial, Mike.
3x squared plus 6x.
Okay, but let's pause there. If you take 3x and you square it, aka multiply it by itself, what does that become? 9x squared. So when you said 3x squared, I'm thinking it would be like that, but you would want to just do that out and write it like that. Does that make sense?
Yeah.
Okay, next term.
Plus 6x or minus 6x.
Very good. Last term.
Root 4.
Plus 4. Good. Nice. Okay. Look at C. Not the difference of perfect cubes. What is making this not a perfect cube situation? What's that? Right. X to the fourth is not a perfect cube, and x to the first power is not a perfect cube. In order to be a perfect cube, it would have to be x to the third, x to the sixth, x to the ninth. But obviously, what can you do here? Take a GCF out. If ever you see a GCF to start a problem, you should always start with that. And then once you take that out, now the difference of perfect cubes kind of comes to light. So I'm going to keep that x out in front, and then I'm going to set up my binomial, trinomial structure. Sarah, what's my binomial part look like? Very good. And Lydia, first term of my trinomial. Good. Second term, Maggie. Good. And last term, Connor.
Plus 25.
Good. Good. Okay. In D, totally and completely not the difference or sum of perfect cubes from the start, but it is 4 terms long, so the natural starting point would be grouping. So you take out an x cubed and an 8. Grouping works. So I'm going to take my x minus 1 out in front, and I have an x cubed plus 8, and this is where that completely part comes in again. You have to take it upon yourself to realize that the x cubed plus 8 can go further. So, again, binomial, trinomial structure. And Faith, what would the binomial look like?
X squared.
And then the other term? I like the plus 2. I didn't love the x squared. So what's the cubed root of x cubed?
X.
Just x.
Oh, okay.
Okay?
Yeah.
And then your trinomial, first term, Alyssa? So when I'm going to, I'm going to not look at the x minus 1 at all because I'm focusing on this one here. To get my first term here, I only look at this one and I square it. Just x squared, yep. Carolina, the middle term.
4 plus 4x.
See, now you're doubling it. Right, you don't double it. I think you're thinking about the shortcut when you square a binomial. And it is not uncommon to get those confused. So this would just be a minus 2x because we want the opposite sign. And Christian, the last term? Plus 4. Good. right, so if you had Mr. and Mrs. Hill, that's definitely a review, yes?
Yeah.
Can you take your headphone out of your ear, please? If my voice isn't music to your ears, Connor, we got a problem. We got a really big problem. For my kids, do you remember this? But we didn't do a ton of it. I know we didn't do as much as the Hills, and obviously for Mrs. Ziggy, this is completely new. Okay? All right, this is going to be new to absolutely everybody, and this is factoring by GCF, but much harder because the exponents are fractions. So if I take you back to GCFs, and I brought this up briefly the other day, and I'm going to say it again because it's going to tie in. If I had a problem start like this, and I asked you to take out a GCF, JR, what would you take out? X squared. And why did you choose to the second power?
It's like the most you do without.
Yeah.
I don't know how that explains.
Because if you took out any more than that, this wouldn't have it to offer. That's actually the way that my mind thinks of it. Some people think of it as, I took out x to the second power because it's the smallest number. Does that make sense? I don't think usually that's conceptually the way it's presented to us, so I don't think a lot of people think of it that way. But you take out x to the smallest number that it's being raised. And what happens is that, JR, conceptually, like what you said, would always hold true. The problem is with the conceptual way of thinking of it, doesn't really work when it's fractional exponents because you're not taking out like a quantity. You're not taking out 3, you're not taking out 4. They're not whole numbers. So the way we think of it has to go to, you take out the variable to the smaller of the two powers. So if you look at the two exponents, 5 halves and 1 half, which one's smaller? The 1 half. Yes.
I think I know the answer to it already, though.
You do? To the whole problem? What is it?
X squared.
No.
Just do it out. You might surprise yourself.
I'm going to do it out.
Okay.
First of all, I'm factoring, so it's going to have to be x to the 1 half in front of another set of parentheses, right? When I take out x squared here, don't I then have to decide what's left of the x to the 5th, what's left of the x to the 3rd, what's left of the x squared, right?
I'm talking about A, or 8A, by the way. I wasn't talking about that.
So am I. So no.
All right, keep going.
I'm going. If you'd let me, I would. All right, so we're taking out the smaller of the two exponents, which is 1 half, and I'm leaving more space than I normally would because with whole numbers, it's easier to do in your head. You've been doing it for years. With fractional exponents, you're going to actually need to think about it, right? If I take, and I'm going to keep drawing back and forth to the comparison between this previous problem. If I took out an x squared from this one above, what is left? X cubed, right? And how did I get there? You just did subtraction because technically what you're doing when you're taking out a GCF is you're dividing it out, right? It's the opposite of distributing. You're actually dividing it out, and your exponent rules say that 5 minus 2 would need to happen, and you get x to the 3rd. That's the same here. When I'm dividing out x to the 1 half, I'm actually going to write it so I can visualize it. X to the 5 halves, when I divide out x to the 1 half, is dividing common bases, subtract the exponents. 5 halves minus 1 half is 4 halves, and 4 halves is x squared. It's there, it's just not the answer.
How? What else is there to offer?
Okay, because you also, so when I divide out, and we'll do this one quickly, if I divide out an x squared up here, that's just minus x, yes?
Yeah. Yes.
And then when I divide out an x squared, it's a plus 1. Because I have to, when I distribute back, it has to give me what I started with. So you have to still divide it out, even though you've taken the entire x squared out, you kind of have to placehold that with a 1 still.
So it's just x squared plus 1?
Yes.
Oh, I've never done that.
I appreciate the effort and the guess. You weren't far off. Now seeing how we got that x squared, did you get lucky or was your logic on the right track?
No, I actually subtracted the half, like the 1 half minus the 5 halves. And
Yeah.
the 4.
Yeah, good. So that's it. Any questions on that? Definitely more challenging. This one. 3x to the negative 2/5 minus 6x to the 1/5. First of all, we have a 3 and a 6. So the 3 definitely needs to come out in front as like your typical numerical GCF. And then when you look at your x's, which one is smaller? Negative 2/5 or 1/5?
1/5.
No, it's not 1/5. You should have gone with your gut, Connor. Connor, you come on. Where's your confidence, JR? Negative numbers are always smaller than a positive number. So the negative 2/5 is actually what has to come out. X to the negative 2/5. And then to see what is left of each term, again, because we're not as used to this, it's not second nature, I really recommend that you divide each term by that GCF. So what will that first term be? 1. And then the second one, if I divide 3x to the negative 2/5, the 6, well, the minus is a minus. The 6 divided by 3 is just 2. And then your exponent rule here, 1/5 minus a negative 2/5 is 1/5 plus a 2/5 is a 3/5, correct? Okay, so x to the 3/5. Now, with this one, why can't I leave that as my final answer? You're not supposed to have what in the final answer? Negative exponents, exactly. So, what moves to the denominator?
The x to the negative 2/5.
Just the x, not the 3. The 3 is not being raised to that power. So you have a 3, and then 1 minus 2x to the 3/5 up top, and then an x to the 2/5 on the bottom. Okay. It's tricky, isn't it? All right. What do I take out? Think about it.
X plus minus the negative 3/4.
Is that Laura? Are you Laura? Who's Laura? Oh. I feel like I don't know you, Laura. So, Laura, you don't talk to me much, so I don't know you. Laura, what would you take out? Say it again. I can't hear you. What to the negative 3/4? You're correct. That's the smaller of the two exponents. But the base here is not just an x. It's an x plus 1, which is fine. We're going to take out x plus 1 to the negative 3/4 power, and then we're going to look at what's left of each piece. So underneath the first term of the binomial, just so I can visualize, I'm going to write x plus 1 to the negative 3/4 power. So what is going to be left of that once I divide? Who's Maya? Maya, what's going to be left of the first term? Just the x. And on the second term, I'm going to line up x plus 1 to the negative 3/4 power. When I divide common bases, I keep the same base, so I'm going to keep that x plus 1 in parentheses. What's the new power? Oh, you're Madeline. Madeline, what's the new power? Just 1. 1/4 minus negative 3/4 is 1/4 plus 3/4. 4/4, 4/4 is 1. Perfect. So two things on this one that we can clean up. This negative exponent has to go to the denominator, and this set of parentheses can be combined. Yes? 2x plus 1 is going to clean up this. Over, that's going to move to the denominator, x plus 1 to the negative 3/4. Oh, positive 3/4. Sorry. That's your answer. Okay, try the last one on your own, and then we'll see what sort of hiccups you run into on your own. Connor, did you pass up your homeworks?
Oh, yeah, anything.
Oh, no, the makeup one.
Oh, I just put it with the other one.
Yeah, you did. Okay. All right, Connor, what'd you get for your final answer?
It's 2x minus 1 over x minus 1 to 1/2.
Like that?
Yeah.
Did anybody get anything different? Lydia, what'd you get?
X plus 1 over x minus
Anybody get anything different? Okay, let's see. So the GCF is definitely x minus 1 to the negative 1/2. And when I take that out of this guy, that really just cancels and leaves me with an x. So where'd your 2 come from? Hold on, maybe I didn't...
X plus x minus
Oh, okay, so maybe I didn't go far enough yet. So x minus 1 to the negative 1/2 out of there. You divide common bases. You keep the same base of x minus 1. And you do 1/2 minus negative 1/2, which is 1/2 plus 1/2, which is just 1. So you have no exponent. And then you just combine like terms, Lydia. Do you see that? So 2x minus 1. So this was the correct one. Nice job. Did you not keep the same base?
I just did 1/2 minus 1/2 and got 0 to split out.
Yeah. So you never kept the base. All right. So on your homework, which is the next sheet. Oh, let's do.
137.
Is that what we did last night? 1 through 7. Yeah, I like that. That's good. 1 through 7, especially because there's people in here that difference of perfect cubes is not as familiar. I'm feeling like school spirit this year. Like this is a pretty good turnout.